I don't know what looks like. I looked at the picture. That takes some pictures. Yeah.
Okay.
I'll let you just.
I'm just gonna come.
Okay, so. I think I'm gonna go to practice though.
So, the date, kind of, it's a brand new date for me. Do you like it? Does it make sense to you? Yeah, okay. Let's do it.
Okay.
So this unit so far has been, I gave you a library of functions. You have those locked in?
No.
Ish, a little bit. Um, maybe we'll do a little worksheet with that later, just to make sure you have them all. And then after you have that library of functions, the point is don't make any more XY charts. You just take things and move them around, left, right, up, down. Those are called translations or shifts. Today we're going to be doing stretches and compressions. So similar thing, except it's not like sliding over, it's stretching. So I'm going to start with an example here. Use a graph of f of x equals x squared to obtain the graphs of g of x and h of x, which you can see both of them have x squared in them. Would you please show me your f of x equals x squared? Did you bring your pocket graphs today? F of x equals x squared looks like this. Your pocket parabola, have it with you at all times, please. And so we're gonna put this dashed on here. So I have my 1, 3, 5. 1, 3, 5, and this is just going to be dashed right here. So you don't have to draw this on yours, but notice that x squared is being multiplied by 2, which means all of the y values are going to be doubled for g of x. And I'll do g of x in just black pen, and maybe I'll do the other one in color. But so this 0, 0 stays 0, 0, 1, 1. The x stays the same. This just goes up to 1, 2. It stretches by a factor of 2. What was it? 2, 4 is not going to be as 2, 8. Right? All those y values stretch. So here's my new one. So 2 goes to 4. I said, was it 4? Now it's at 8. And I think that's it for the right side. And same thing on the left side. All those y values have stretched. And you know, I'm a big gesture guy. So what do you think a good gesture for a vertical stretch would be? Vertical stretch, I really need you to grab on the top and the bottom and stretch. Right in the middle, of course, is the x-axis. So stretch, middle is the x-axis. So 1/2 x squared, those y values are going to not be stretched, but compressed. And it's a vertical compression. So the gesture, of course, for vertical compression, take the top, you take the bottom, and squash them together. If you want to call it a vertical squash or a smush, you may. The technical term that we normally use is compression by a factor of 1/2. Compressed by a factor of 1/2. So as promised, here's my other color. So that 1, 1 is now going to be at 1, 1/2. What used to be at 2, 4 is now at 2, 2. What used to be at 3, 9 is now at 3, 4.5. Is that clear? On both sides. Once you have your one side, you don't really have to consider the other one too much. Just kind of replicate it. And this is enough points. But do you see from the dashed one, do you see that the solid one is a stretch? Like if this desk were made of like a rubber band or something, you pulled on it, that would be the dark one in the middle. If you somehow squashed the rubber band, it would widen out into the red one that I have here. So that is a vertical stretch and compression. Notice a difference here. Notice where that 2 and the 1/2 is. They've changed, haven't they? Here, 2 is on the inside of the function, which means it's going to be affecting the x's. Like last time it was horizontal, if it was inside, it's still horizontal, but it's going to be either horizontal stretch or compression. So that 2x, remember when things are on the inside, like here, the warm-up, minus the things to the right, it's opposite of what you think. So that 2x, that 2 is actually going to be a horizontal compression by a factor of 1/2. So this is horizontal compression. By a factor of 1/2. If that would have been a 3 in there, it'd be a factor of 1/3. If it would have been a 4/5 in there, then it'd be a factor of 5/4. Exactly. So you take the reciprocal of whatever number is inside. So we're just going to take some key points here. I'll start with the left side. Is this like some sort of parent function? Do you need to have this one in your library? No, this is just for this problem. They've given this function. This -4, 0 is going to be moved to -2, 0. Squashed. Right in the middle of the squash is the y-axis. So that's -4, 0 becomes -2, 0. I think you could do this one in pencil. I guess I'll do this one in green. The next point I'm going to move is, you could do this. You could do the rest of this, please. Check with your neighbor, make sure it's okay. I'm going to call on someone to help us out with this. Okay, folks. We talked about at this point, -4 is 0. What next point should we talk about? I'm going from left to right, but you're right, the origin is 1. But before that, let's go up here. So -2, 4. What's going to happen to this? Gonna be a horizontal compression. So just this is going to move right over there. Does that make sense? Yes. So these are just horizontal compressions. So we're not changing the vertical at all. We're not like, you're not doing zoom in. This is just a horizontal compression. All the x values are moving in. So this goes here to -1, 0. 0, 0. Stays right where it is. Anything at the origin with compressed or stretch is going to stay there. Do you have the rest? No. I'll give you a moment to take. I need 2 more points. Okay. So Luke, what do you think? What should we do next?
Down 3 and to the right 1.
Are we good with that, everybody? So it's this point that's been compressed. 2 became 1. And do you have another one?
Yeah. And back up 3 and go to the right 1.
Okay, so like right there. Now, I appreciate that you're going from here to here. That makes sense to me. I think in the purpose of this class, how we get here is from. Oh, look, do you know where I'm getting?
Yeah, this is back 5.
Yeah, we're just, all of this is being compressed. Right? Horizontal compression, so all just moving in by a factor of 1. And now that we have our key points, is it difficult to draw a new function? Just make sure that this one is rounded like it was originally, and then this one is this and this. And I hope you can see from the black to the green, in mine, it has been compressed horizontally. Yes, it has.
So since it's inside of the function, it doesn't up or down, it just like gets small, it's like in width.
Since it's inside and multiplication, it's either going to be a horizontal stretch or compression. So since it's times 2, it's going to be it's opposite of what you think, which is difficult to hurdle to get over with that inside changes. So this one, h of x, what do you think is going to happen to this one?
Multiply it by 2.
It's like a double by 2. But let's just check to make sure that what we're saying is correct here. Have you plugged? Oh, it jumped out of my hand. If you plug in 1 right here, you get f of 2, correct? What is f of 2? Do we know what f of 2 is? Check with your name. What is f of 2? You see what f of 2 is? Can you hold it up? F of 2, I'm looking for a number. Well, let's kind of follow the math. Okay, so I'm trying to figure out if this is correct, right? So I plugged in a 1 into this craziness. G of 1 is the same thing as f of 2. To find f of 2, we look up here. So f of 2, that gives us a y value. So I look over here. Oh, not 2, it's negative. Sorry, I should be looking here. F of. Okay, back up. I was thinking the wrong thing.
Oh.
G of 1. This is just a quick check. Excuse me. I'm sorry to confuse you here. So here's a check to make sure I just went the right way. G of 1 is equal to f of 2. Isn't it? Just plugging in a 1 right there. So to find f of 2, I look at this one. Y is f of 2. So f of 2 is, it should be negative 3. Okay, and here's it. Oh my goodness. That was terrible. I'm so sorry. We can see here on the graph that G of 1 is equal to negative 3. And we can confirm that by looking at f of 2. Let's forget that ever happened. Let's talk about h of x. This one is a stretch by a factor of 2. I'm going to do this one in red. So that negative 4 comma 0 is going to go to negative 8 comma 0. I'll let you do the rest. And check in with your neighbor. Are we ready? You need to check in with it before I call on you? Okay, just Siri, did you get any more points?
The other side, 8 on the origin.
8 on the origin.
Well,
8.5. So where are you getting a point from?
I just copied what happened on the other side. The
Okay.
transfer.
Okay, the green one or the new
The
one?
new one.
Let's think about where this point came from. Any idea where that came from? Pardon? Thank you. Okay, well, do you know what the coordinates of this point are?
Smith 4, -2.
-4, 0, I think is what you meant. Okay, and the new one?
-7, 0.
So I made a mistake with that one, didn't I? It should be -8. Excuse me.
Oh.
-8, 0. Sorry for the mislead. Once again. So it's -8 because all the horizontal components are being stretched by a factor of 2. -4 goes to -8. Which point do you think we should work with next from the original function here? Just here, which one do you think we should work with next? From the original function. Well, if I'm going around here, I'm looking for a key point. I could use this point right here, this point, this point, this point, this point.
Oh, the top one, the graph.
The top. Okay, and the coordinates of that point are?
-2, -2, 4.
Yeah, this is -2, 4 right here. So what's going to happen to it?
Stretch it.
To what?
To -5, 4.
Well,
-6.
remember, how did we get from -4 to -8?
You stretch that by 2 or double it.
You doubled it. So if it's -2, 4, you take that -2 and make it
-4, 4.
-4, 4. Are we okay with that?
Yep.
0, 0 is going to become 0, 0. Take my other key points. 2, -3 is going to become. Sorry, so yeah, 2, -2 is 2, -3 is going to become. See, 2, -3 is going to become 4, -3. And then the last one, guys, 5, 0 becomes 10, 0. Does that work like that? And now that we have our key points, so thank you for going through that journey with me. If you see me make an error, could you correct me before I run with it? Like that, when I plotted the accident labeled this and call me -8. So let me know if you see it. Don't be shy. It's something like that normally looks like, wait, kinda, right? When you see an error. Exactly, perfect. But I hope that you can see that the red one compared to the black one is a horizontal stretch, isn't it? It's all been perfectly stretched. The vertical has stayed exactly the same. The green one compared to the black one is a horizontal compression. And those are the two things we're doing today. Oh my. So an important note here. Order of transformations. What's going on? Does that look familiar? Das, gentlemen. Yeah. So like PEMDAS, but we don't have the parentheses and the exponents. The parentheses, it just tell you what's inside, what's outside. So we don't need that. Exponent tells us if it's a quadratic, it's a cubic. So we don't need that. We just go to this. So multiplication and division comes first. And then this comes second. So this 1/2, notice that this is inside or outside the function. It's outside the function, so it's going to be, well, I'll give you a moment to talk about this with your neighbor. The vertical stretches, compressions, and slides. I think it's maybe the easiest word to call them. So what's happening here with the 1/2, the 1, and the 3?
I guess so.
The 1/2? Can you show me what it is?
Yes, for.
Can you show me? It's outside, so it is vertical compression.
Yeah.
By a factor of 1/2. Vertical compression. I'll say times 1/2. This 1, please show me what that 1 does. It moves it to the right. 1 to the right. And then this 3 is going to move it 3 up. So I'm going to do them on here. And the order that I need to do it is first, anything that deals with multiplication and division comes first. In other words, this comes first. And then these. Doesn't matter which one, addition or subtraction, that go either way. So this -4 stays right there. There's -4 comma 0. And then it moves 1 to the right and 3 up. There's -1. And I'll do this in a different color. If you discuss with your neighbor what's going to happen to this top point right here. This point, -2, 4. You didn't discuss? I just want to know what's going to happen to that one point. Okay, Upton, were you able to get anything from there? Let's do it together. What comes first? Yeah, vertical compression of 1/2. So this point is going to go from -2, 4 to where? Compression. It's just a vertical compression. So it only moves this way. So -2, -2, 2. And then from there,
-1.
yeah, exactly. We're going to go 1 to the right and then
Up 3.
yeah. That's the weak point. Is that clear?
Yes.
You're given the directions here and you just follow them. So compression here, compressed like this. From 4 down to 2, over 1, up 3. So 1, 5 is what we're looking at here. I'll give you a minute to finish the rest. Has anyone finished the rest of this one? Protect the people around you. Yes. Yes. But enough of the compression, of course. Yeah.
So
Are you ready? I want the rest of the points. I want the rest of the key points anyway. Jack, can you help us out with these?
I'm still working on
Okay, I'll give you another 30 seconds or so. Thank you, Gideon. Jack, which one are you working on?
it. All of it, sure.
Oh, so did you do any of them?
Well, I'm getting all the.
That's
because it's compressing by half.
Why are you doing calculations?
Yeah.
Why?
Because I think it's, makes more sense to write it down.
It doesn't. Sorry.
Because we were all done half an hour ago. Not all, of course.
But I always mean.
A few. Okay, can you tell us what you had? And I like what you're doing, by the way, so I'm gonna ask you to kind of go through it if you don't mind.
Yeah, so I was just writing down all the original coordinates.
Okay, so I'm gonna like go to 0, 0. So like this, and let's just do the ones that we haven't done. Okay,
And then I multiplied the x by a half.
okay.
Yeah.
The X by a half?
Sorry, y
Okay,
by a half.
so times 1/2, so this became 0, 0, and then,
And then change the x to +1 to add.
okay,
And then add 3 to the y.
okay.
Yeah.
So you got 1, 3. This is fantastic. Thank you for showing us a different way to do this, by the way. So, sorry for giving me a hard time with that, but this is really, really nice. Can you show us with 2, -2 also? Yeah,
Yeah, so I did 2 minus 1. And then,
2 minus, you subtracted 1?
oh, sorry,
I think you're multiplying by 1/2 perhaps? I'm not sure why you're saying 2 minus 1.
oh, wait, yeah, okay, okay. Yes, yeah, okay, so 1.
So-
1 minus 2,
Oh, 1 -2, I see.
yeah, 1 minus 2, and that's,
That's a -2.
yeah, yes,
Okay.
and then, 2, then to be 2 minus 2, and then, 2, 1,
Feel like there might be a little confusion.
2, the x.
So X is not going to change right now. Oh, I see. Are you adding the 1 to that?
Yeah.
Okay. So 2 -2. And then 2, 1. Like this. Okay, I want to check this. So we have the first
Right, dude.
2 -2. This becomes, excuse me, vertical compression. So -2 becomes a -1. So the point goes here and then moves to the right 1 and up 1, 2, 3. There should end at 3, 2. So something strange happened. Did I do that wrong? Is it 3, 3? I don't think so. I just followed directions. I need everyone's attention up here, and I appreciate your struggle through this. And Jack, I definitely want your attention up here.
Yeah,
Definitely.
yeah.
I like your method.
I'm just trying to figure it out.
Yeah, and I think if you have both, it's gonna be set. So I'm just taking coordinates here and I'm following the directions. Vertical compression of 1/2. That's why this squeezes from that -2 to -1. And then from here, it's just to the right 1. And then 1, 2, 3. Done. Okay, so there's one more point. Jack, did you already get the last point? This one right here.
You gotta have to. Yeah, it's not getting the number bigger.
The compression take equals there.
Yes.
And then?
It's not down. Plus and plus one, so yeah, 5 0 and then 5.
5, 3. And does this array of points make sense compared to what we started with? It's kind of zigzaggy, but we started zigzaggy. So we start with this curve right there and then connect those dots. That's what I'm looking for. Make sure you understand what just happened. Because you're about to do example 4. Jack, thank you for struggling through it that way.
Yeah, no, I don't really know why I wrote this.
Well, it works. It does work. If it's done correctly. See, the mistake was it should have been 2 -1 to right off the bat. So you're starting with your parent function here, aren't you? That parent function, you're going to dash it in. Are we okay with this parent function here? If we haven't already, just take a moment to discuss what's going on with the parent function that's going to happen to it.
Up to right. Um, it's gonna be- Actually, not for right. I know it goes up to.
Well, it's not.
I wanna see what goes right.
Yeah, but that's only.
Okay, can you show me what this 2 is going to do? Everybody, show me what the 2 is going to do. It's outside, so it is a vertical stretch by factor of 2. This 1, show me what that's going to do. Move the whole thing to the right 1 and then 2 up. So again, you're not making any sort of table of values, you're just taking each one of those points and doing these 3 things.
It's because the reason there's the cube is that something that will come out of sheets.
So far, see this.
Can I call on someone? You need to check with your neighbor? Okay, another 15 seconds before I call on someone.
One goes to well, is plugged. Yeah.
Okay. So Raquel, can you help us with these?
So,
Let's go from left to right. So starting with that point, -8, comma -2.
oh, okay, so I mean. Oh, that's not the side I started, I started on the right side.
Oh, let's start on the right side. Or do you want to come up and show us what happened? Or talk about it? Sure.
So I moved, I kind of, I started with the origin and then just kind of went to the right.
Oh, start with them. Okay. Okay.
So so the origin moves to the right one up to, so the new origin is now 1, 2.
Okay.
And then the second point also moves to the right one up to, but then I'm pretty sure it doubles.
Okay.
So I think the new point is 2, 4.
Okay. Are we good with that? 2, 4? So the way that, and you thought about it correctly, well, you ended up correctly, but what I like to consider is do the stretch first. That's why this 1 goes up to 2 first, and then over 1 and up 2, I think. And so you landed in the correct place. You didn't overstretch. Yeah, it's fine.
So then, this one also doubles, so I believe it goes up 2.
So H2 becomes.
So it went up 2, and then I goes to the right one and up 2 again.
Are we good there, everybody? 9, 6, is that right? Okay. So we've done the origin and the ones from the first quadrant. So this point here, -1, -1.
Oh, yeah, so now it's, so the next point would be 0, 0, I'm pretty sure.
Yeah, so stretches by a factor of 2 into the right one, up 1. Up 2, excuse me. And that last one.
Is it like -9, -6?
Let's see. -8, -2. First thing that's going to happen is a vertical. So the vertical is down. Vertical stretch by a factor of 2. Right, so that we stretch that vertically by a factor of 2.
Okay, so yeah.
And then from there,
So then it goes.
then we go 1 to the right and 2 up. Yes?
Yeah.
Is it following the path, right? It's given direction. So stretch. I hope you can see this as a stretch. We're pulling this down. It was at -2, now it's at -4. Over 1, up 2. What do you think, Raquel? Does that make sense? Is that where you ended up earlier? Okay. Cool. So now we have this, and it does appear to be in a arrangement that makes sense. And this is what I saw in a lot of students' papers. So, whew, that was a lot. Raquel, thank you for helping with that one. You have some time to work on your assignment. Thank you.